Hi, my name is Carter Kraft, and today my presentation is on the effect of electroculture on the growth of microgreen plants. Now, a bit of background info on this is that electroculture is a method of growing plants where you take uh, electric current, usually AC or DC, and you will introduce it to these plants, and it through studies it is shown that it increases growth by about 25%. It also increases leaf health and general overall resistance of the plant to different types of disease, funguses, stuff like that. Now, what are microgreens? You're probably wondering. Is microgreens are plants harvested in the cultul culinary stage. Colander. I'm gonna call it colander. The colander stage. So when they're just youngins, like these strawberries right here, that is about when they get harvested. But the reason they're harvested here is because plants in this stage tend to have a lot more antioxidants, a lot more minerals, vitamins, stuff like that, stuff that makes a healthy diet. And my level of thought is if we could find out how to grow these more efficiently and produce these to where they have a higher growth rate, higher resistance to any type of disease that can spread through a what is it called? Like massive microgreen farm on a in a factory scale. Then it would be a much more efficient food source for stuff like salads. We could have these set up in low income areas like community gardens, and it will help just improve the lives, maybe get a lot of population's vitamin deficiency down. Now, my methodology for the experiment is I had two sets of petri dishes, each with grow pads in them, with a made out of materials similar to peat moss, and one of those groups, each group consisted of six petri dishes, and one of those groups had was connected to 12 volts DC current, and the other one was connected to nothing, but it still had the graphite rods in there just to make sure that our results will be the same, consistent, stuff like that. Plants were left to grow for 10 days, which we used broccoli microgreens in this experiment. Uh, because they were probably they're one of the most nutritious ones, and they were the quickest to get. They were left to grow for their germination time of about 10 days till I'm all sprout, and by the end, when we harvested them, we took the uh, we took the weight of the microgreens in the peat moss like grow mat, and we took that and measured just that, and then measured the empty weight of the petri dishes they grew in, subtracted that from that, and then divided the weight of those totals by 90%, which is about the water absorbency of both the microgreens and the peat moss. So we can hopefully get a more accurate dry weight. Now, after that, we put our uh, weights through a two-sided twin-tailed t-test. And after the math came out, we ended up getting a p-value of 0.21%, which exceeded the threshold of the 0.05% that we needed to disprove the null hypothesis. So currently, this doesn't have, there's no proof that this would work. But in the future, I would like to use a more sterile environment. Somewhere in the experiment, we had a mold infestation. We had to restart the experiment, so we couldn't do it on such a big scale that I wanted to. But bigger, if I were to do this again, bigger scale, sterile environment, maybe a better growth setup, but I need to plan that out.